To affect the blood. Blood wants to say no. Let's keep it right. Oxygen, CO2, met. Or effect. And then, oh man, this one right here. BPG. Okay, the reason I give y'all an introduction to this, your book will get a little more detail. But the reason that I bring it up, when you encounter people that are going to be sick, and let's face it, you're going to encounter that, right? I would think so, yeah. Okay? And BPG, this bisphosphoglycerate, okay? In people that, say for example, have cancer, who have COPD, believe it or not, like for example, people with COPD, the tissues are working so hard to try to carry out ventilation that their metabolic rate is high. All right? Doesn't mean that movement of the gases is occurring correctly, but their metabolism, because metabolism is what? What's the definition for metabolism?
Some of the anabolic and catabolic activity.
It is the sum of all chemical reactions of the body. So for example, people with COPD, metabolism is going to be high. They're going to stay hungry. They're going to eat. They'll never gain weight because their body is actually burning calories about 4 times higher than the normal rate. And we're talking about people who really aren't moving around. Cancers, as they begin to grow, demand more energy because the cells never stop dividing. So therefore, a metabolic rate has increased. So BPG will be a lab reading that you will see on a patient's report because they can test for that. And what it is, it's an intermediate for those red blood cells. And because we are demanding so much energy, remember, cells that are busy are carrying out a lot of their energy making based upon anaerobic fermentation. Okay? They're not going into mitochondria to make it by way of aerobic. This can alert doctors, okay? It can be clinically significant, all right? But a lot of times, if you've already been diagnosed with a disorder such as that, they already know these levels are high, okay? But under other conditions, BPG, because cells are acting anaerobically, think about somebody running a marathon, okay? BPG would be high, and that would help release oxygen to those tissues for that short amount of time. Under chronic conditions, somebody with a disease, that number is going to stay elevated all the time. Okay, so you will encounter BPG as you go forward. Carbon dioxide loading, I think I pretty much mentioned that quite a bit. Cells are busy. They move the CO2 one of 3 ways for it to be transported. So what does that tell us? Just like we had the Bohr effect for the drop-off of the oxygen, we have the Haldane effect for picking up the CO2. Get it, transport it, get it out of the body. So all of this is working with our respiratory system.
For the BPGs, in the hospital we have a test that like respiratory therapists do like in a situation. It's called ABGs. I don't know if they're like related. It sounds like
I don't know, but I'll look it up.
Yeah.
Because
It's usually we call it rapid. Respiratory therapist has to come in.
is
They're calling it right
it if the patient is in rapid breathing or something?
Yeah, usually it's respiratory therapist does it, so it's definitely like with the O2 stats and respiration rate, things like that.
And it's called
But-
APG.
ABG.
ABG.
So that
Yes,
was a B.
arterial blood gas.
Arterial blood gases. Okay.
Before right here.
And I know I've heard, I was with a friend who had to have that done. But that's because that respiratory therapy is not my thing. But I'll look it up. Arterial blood gases. Because I know that arterial, so
I didn't know
artery.
because it was
So artery,
BG
so-
and BPG is like
Yeah.
that's what the
But we'll look that up every time. Yeah. See, y'all making me think again. I like to think. Okay, so respiratory rhythm, hey, ventilation, right? Inhale, exhale. Respiratory rhythm. If you remember, we have different effectors that will control, you guys remember neural control, dorsal group, ventral group, all that sort of stuff, that are going to help us control rate and depth, okay, so that we can meet normal values. Those respiratory centers of the brain are working to help do this because what we want to make sure is maintaining homeostasis of the body and therefore meaning we meet the demands of the oxygen, pickup of the CO2, and so forth. And an area of the body that is hugely affected by pH changes, the brain. The brain is actually going to monitor itself and demand blood flow first. So these peripheral chemoreceptors, remember, to the outside of the body, we have them monitoring CSF, cerebrospinal fluid, the fluid that washes over the tissues, okay, of the brain and the spinal cord. The most potent chemical to those tissues, and like I keep saying, CO2 is toxic, so therefore pH. The most potent chemical is the level of the pH. So we're going to find in the medulla oblongata those central chemoreceptors. You remember the ones within the brainstem? Okay. And they can affect respiration quickly because like I said, the brain is monitoring itself. And one thing it wants to do is keep its tissues in proper working condition. So, H pluses, which affect the pH, they don't get to cross the blood-brain barrier. Do you guys remember the blood-brain barrier? The glial cells that will reach out and wrap around the blood vessels and so forth and keep materials from moving in and out. So it won't allow the H pluses, but it can monitor the CO2. CO2 rises if the pH in the blood goes up. Is that correct? Well, I guess we should say, pH lowers because of the acidic scale, okay? And if any carbonic acid is produced. But we can't buffer it. So what we've got to do is the brain has to bring in more oxygen. So therefore it would have to increase its blood flow. So the brain is like its own circulatory route. And you see that. When you look at circulatory routes of the body, the brain has its own special circulatory route, all right? Because it's demanding, the only molecule it can use is glucose, so it demands a lot of glucose. And then if it's monitoring pH, it's going to be demanding its oxygen. So it has its own special circulatory route. Now, the second control of respiration is CO2. CO2 affects pH. pH is affected by CO2. Okay? So, CO2 can have a little bit of an effect, even if the pH is stable. For example, at the beginning of exercise. But at the beginning of exercise, because the cells of the body can adjust, blood flow can adjust, respiration can adjust, heart rate can adjust, okay? It's only a very small amount of seconds, and the body is adjusting. If you think about someone who's at the beginning of exercise, okay? Well, one of the things that hopefully they've done is they've warmed up, okay? Which would be increasing blood flow. And then once they actually begin the rigorous exercise, it's only about 10 to 15 seconds, and the body is already adjusting. That means you're breathing heavier, your heart's beating faster, and so forth. So it will meet the demands of those tissues. The last thing that controls anything about respiration is oxygen. It's the last thing looked at. Certain diseases and disorders will affect that, but for the most part, oxygen is not what's affecting our respiration, which seems kind of odd, but that's pretty much the way it goes.